Dear students, in last module, we started an example of insertion sort, and in today's module, we will try to complete that example by going into the details of each and every step that how that list is going to be sorted. So remember, we had these 5 names: Fred, Alex, Diana, Byron, and Carol. And we wanted to sort it in the ascending order, which means the name which is Alex, which is the minimum name, or starting with the letter A, will be placed on the top, followed by B, Baron, and C, Carol, D, Diana, and F, Fred. So the procedure we discussed was that first of all, we will consider that the topmost element is in the sorted order, and we will consider the next sublist as unsorted list, and we will pick the topmost element from the unsorted list and we'll try to put it or compare it with the topmost element which is available in the sorted list, and we will continue this process. So let's continue it with a proper example. Let's do it. We have basically the list Fred, Alex, Diana, Byron, and Carol. So we are at the moment here. So first of all, we consider, and to read this picture is that anything which is displayed with the white background is actually sorted, and anything with a blue background is unsorted. So at first place, the top mode sorted has been white background, and this one is unsorted. And similarly, you will see it in the next all of the iterations. So first of all, we have picked Alex from here because this is the topmost element from the unsorted list, and we have compared it with the Fred. When we compared with the Fred, we found that Alex is less than Fred. Actually, how it is done at the backend side is based on the ASCII codes which we learned in the initial modules. The ASCII code of Alex are compared with the ASCII codes of Fred. So this process goes in the following direction, that the ASCII code of A is first compared with the ASCII code of F. So ASCII code of A is 65 and the ASCII code of F is of course greater than 65. So B has 66, C has 67, D has 68, and F has 69. So 69 is greater than 65. So which means Fred is greater. So this is basically the backend process. And when it found that this is greater, this put Alex upward and Fred downward. So here we need one location where we can put Alex so that this location becomes empty, and here we can put Fred. So this means we need only one location as a temporary location where we can store Alex for few moment of time, so that the second number location is free to be placed Fred at the proper location, and the first location is now available, which is in which we can put Alex. So we have put Alex over here, and you can see that this temporary location is now empty. It doesn't contain anything, but in future we could put some other things in this location. So this would be only one location. So the next step would be that you can see in the second step, now we are going over here. So Alex and Fred are sorted, and Diana, Byron, and Carol are unsorted. So we will pick Diana, the first element from the unsorted list, and we will put it in the temporary location, and we start comparing with the A. So Alex. So Diana, the D in the Diana will be compared with the A in the Alex, and it will found that D has greater ASCII code as compared to A. So this means Diana is greater than Alex. So it will say, okay, Fred, you should move downward. So it moved Fred over here, and there is only one location where the Diana can be placed. So after the conclusion of second step, Alex, Diana and Fred are actually sorted, and the list in the blue background here, Byron and Carol, is unsorted at the moment. So then the third step is we have Alex, Diana and Fred as sorted and Byron, Carol as unsorted. So we are picking Byron from here, and then we are putting their dead Byron in the temporary location, and then we start comparing with the Alex. So when we compared it with the Alex, we found that the Byron is greater than Alex. So this means we need a location over here. So we inserted this over here by moving all of the elements downward. So Fred is going downward, Diana is going downward, and we have the empty location over here where we will put Byron. So we are not going into very much technical details of this insertion sort, that how actually it is doing and comparing the values from top to bottom or bottom to top. But at the moment we are just concerned about that how this algorithm is working. And then at the end of this third step, Alex, Byron, Diana, Fred is basically sorted and Carol is not sorted. Then the Carol is picked up and the location is found, and that Carol is put in that location. And after the execution of this fourth step, all of the list is already sorted in a proper order. So if we conclude today's topic, we have learned a practical example of insertion sort, and we have applied the philosophy which we learned in the previous module, that how actually the insertion sort is working and how it is helping us to sort the elements properly.